Okay, so for homework 3, the problem is given an array of unsorted integers and an integer k, return the kth largest element in the array. If the array is empty or null, return null. So we can't use arrays.sort or .sort in Python to solve this problem, and the problem should be O of n log n. The assumptions I'll be making is that integers may be positive or negative, and that k will always be greater than or equal to 1 and less than the number of elements in the array. Okay, so basically to start this problem, looking at it, since I can't use the sorting methods, I'll probably put everything in a tree map, because once I put in a tree map, it actually sorts for me, so I don't have to actually create a sorting method. Putting in the tree map will actually sort it. And to find the kth largest element, each node in the tree map, I guess, I'll put the key as the actual value in the array, and the key's value will be the number of occurrences of that value in the array. And basically at the very end, I'll basically loop through those keys and basically subtract out the number of occurrences until I find the kth largest element. And that should be O of n log n. So, okay, let's start coding. So when I start, let me make sure I didn't miss anything with the exceptions. Okay, this function is called kth largest element, so return int largest, and it takes in an int array and an int k, which is the kth largest element. So the first thing I would do is first do the checks. So basically, if array equal null, or array dot length equals 0, then you can just return -1 because that means the array is empty, or null. Okay. So that handles for that cases. So then I would set up basically the map. So I would do map integer, and I call it a map, and that would be basically I'll set that up as a tree map. So this is basically just setting up the actual tree map to be filled. Yeah, so that's how you're setting it up, setting the tree map, and now basically I would just loop through the array and store it in the tree map. So this is just a storage portion. So basically int I equals 0, I is less than array.length, and then I plus, and then I would basically just have to do the storage part. So my first thing would be check basically if that value has already been accounted for. So then you would just have to increment the number of occurrences that value maps to. So I do basically if map.contains key contains of array. So if it's already there, then you're basically just going to increment up the value that's mapped to the key, because that represents the number of occurrences. You're going to increment that by 1, basically to account for another occurrence. So I'll probably set up another variable, and let's call that amount, and that basically equals the value that's already there. It should be 1. So it should be map.get, I believe, because you're getting the actual value. You're getting the value at that key. So you're getting get array I, and then you can increment that by 1, because you're counting for another occurrence of that value. So you're incrementing by 1, and then just put it back in the actual tree. So you do map.put array I, which is a value, and then the occurrence is amount. So now you've accounted for another occurrence of that value in the array, in the actual map. You've handled that case. So now this is like, if it hasn't been seen before, you just have to do map.put array I, and then 1. Because it hasn't been seen before, so it just happens once for that value. Okay, so now you've basically done the storage of it actually in the array, or sorry, in the tree map. So now basically is where you loop through that tree map and basically subtract out the occurrences until you find the kth largest element. So here you would basically set up a variable, I call it int x, which would basically represent the back of the transversal, because since the array has to be inverted, you want to transverse through the back. So you're going to have to do basically array dot length and subtract it by k to basically count for starting from the very back of the array. And then you would basically loop through each key and see the occurrences n, and basically incrementally subtract out the number of occurrences until you hit the kth largest element. So to do that, you would probably have to set up a for loop. And going through the map, you would do integer I, and then you would account for map. And this would be all the keys, so you do key set, I believe. Key set of all the keys. And then you would have to basically do x. You would subtract out. You would have to subtract out a value. So actually you would need another value. You need int current. You need to keep track of basically where you are within it. So it would be map.get I. So you're actually keeping track of the value you're at. And then you would basically just do x minus equals current. So you need to subtract out that value basically to subtract out the number of occurrences. And basically, because basically current is the number of occurrences that is mapped to the current element. So you need basically subtract that out from x. And basically once you hit 0, you've subtracted out the total occurrences and you've reached the kth largest element. So now you can just do a check to basically do if x is greater than or equal to 0. That means you basically successfully subtracted everything out. Oh wait, it could be less than. If x is less than or equal to 0, then you successfully subtracted everything out, and you can just return. You return, I believe I. Yeah, because return I is actually the value. The kth largest element, I guess, is the value, not just the key. It's the actual value. So now that you have that, you've handled the return case. And if you don't hit less than or equal to 0, then that means you haven't found it and you haven't subtracted it out. So you would basically just return -1 because you have not found the kth largest element. And that something went wrong and you weren't able to find it. So you just return -1. Just look over my code, make sure that I handled all the cases. So I did handle the null case and the array length case. Return -1 there. So basically a good case would be if you have, I don't know, the array 1, 2, 3, 4. You don't find the kth largest element of that. You basically put in the tree map. You basically map the number of occurrences for each value in the array. And you put it in the tree map. And then you subtract that array length minus the kth largest element you're trying to look for. Which could be 3 for this example. So the third largest element would be 1, 2, 3, 4. Not 4, not 3, but 2. So the fourth largest element is the first largest element, second largest element, third largest. So it'd be 1. It'd be 2 for the third largest element. So you basically loop through the keys of that, find the current value, and basically start from the very back, find the current value, subtract out the number of occurrences, so x minus current. This would be cur, and that should push you back at 2. So when x is less than or equal to 0, because it's going to give you a negative number, you've hit that value too, and you can just return I. Yeah. I think it might be off by 1, so right here I'll just subtract 1. Yeah, it was off by 1, sorry. So, but if you subtract by 1 there, it should give you a value less than or equal to 0, and that means you've hit 2, and you can return that value 2. So that should work. Basically, the runtime of this would be O of n log n, because the actual putting in the tree map is n log n. So that's where the O of n log n comes from. I think I've shown all 3 cases. And walk through a sample good case. And Yeah, I think I've handled every case. So that's exactly how I do the problem.